So let's take a look at proving triangles congruent by side, side, side. If there's a correspondence such that 3 pairs of corresponding sides are congruent, then the triangles are considered congruent. Here we are given AB is congruent to CD, AD is congruent to CB, and we can use the reflexive property to say that BD is congruent to itself. So I begin my proof. If you're writing this on note paper, you would need to copy down the given in the proof statement, copy the diagram, and mark it. So I have segment AB is congruent to segment CD, and that's given. I'm also given segment AD is congruent to segment CB. Then, by the reflexive property, I can say that BD is congruent to DB. So now I have triangle. How I order the first one doesn't matter, but however I decide to label this first one, if I go like this, don't draw the arrows on your diagram. Well, you can on the outside, at least for now. But technically, that's not an appropriate marking. So triangle BAD is congruent to triangle, let's see, I started here and I went over the 2 line, the line with 2 ticks. So that means I need to start here and go that way. And remember, the order does matter because we need the correspondence. So BA is congruent to DC, AD is congruent to CB. And then in the margin, I'd like you to note the lines that have the sides, and that's lines 1, 2, and 3 in parentheses. That doesn't make a whole lot of sense to do the left margin notation and the parentheses notation right now because our proofs are so short. They won't be this short for long. Let's do another example. Here we are given AB is congruent to ED, AC is congruent to EC, and BC is congruent to DC. So we have statements, reasons. Did I mark my T-tool? Yes, I did. Technically, you could lump the givens together, but if I do that, I'll do that and then show you what would happen if you do it, and then show you kind of why I don't recommend it. So now I have side, 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 if I lump them together. So I can say triangle CAB. They started that for me, but they didn't name the second triangle. So C to A to B would have to be congruent to C to E to D. And that would be side, side, side. Now when you do this, you have to have a correspondence. The first pair of sides is in line 1. The second pair of sides is in line 1. The third pair of sides is also in line 1. So if you do lump this together, you still need to write 1 3 times. That's why I would not recommend that. Remember, you have to assume that your reader doesn't understand this and you're trying to explain it to them very, very clearly. Moving on to our next proof, our next example, we are given MS is congruent to HS. U is the midpoint. A midpoint divides a segment into two congruent segments. And then I can use this as reflexive. So S to U to M is going to be congruent to S to U to H. So now I'm going to begin with statements. Reasons. MS is congruent to HS is given. That's my side. I think it adds to readability if I almost insert a little space, almost like making a new paragraph when I'm going to prove my next pair of congruent parts. So U is the midpoint of MH was given. And from this, I know that if a point is a midpoint, that it divides the segment into two congruent segments. And I'm making that inference from line 2. So now I know that UM is congruent to UH. That's another side, leaving a little space, because now I can say US is congruent to US by the reflexive property. That's also a side. In line 5, I now have triangle, SUM, congruent to triangle, SUH. And remember that correspondence, SU needs to be congruent to SU, UM needs to be congruent to UH, and SM needs to be congruent to SH. And that was by, number 5, side, 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 lines 1, 3, and 4. I used line 2 to create line 3. Finish my T-tool. So I marked my diagram completely. I have my left margin labeled with sides and angles that I'm using, in this case just sides today. I noted the two triangles that are congruent. My statements and reasons are numbered each and lined up across from each other. So now we have PU congruent to KI, UM congruent to IN, and PN congruent to KM. Those, however, are not sides of the triangles, are they? What I need is PM congruent to KN. What I need to take away from the lines with 3 tick marks is that. So now let's start our proof. I think getting that third side of PM congruent to KN is going to be the most confusing. So I'm going to choose to guide my reader through that as quickly as I can right off the bat. So I'm going to start with PN congruent to KM. Then I can say that MN is congruent to NM by the reflexive property, then Pn minus Mn gives me Pm, and Km minus Nm gives me Kn. And now that we've finished chapter 2, you don't have to tell me if you're subtracting the same or congruent angle or segment implies congruent segments anymore. You can just tell me subtraction. And that is a side of the triangle that I need. So now, leaving just a little space, I'm going to state PU is congruent to KI. And I want to point out that everything, I'm kind of lining up everything here. This all corresponds to this triangle. Everything that I'm writing over here is going to correspond to that triangle. So I'm trying to make it easy for the reader to follow as I'm writing this. That's another side. And then UM congruent to IN is also given. Zoom out a little bit here so that you can see the final line of the proof, where we have to conclude or prove that triangle PUM is going to be congruent to KIN. And again, those arrows aren't really proper notation, so I'm going to remove them. So now in line 6, I can say triangle PUM is congruent to triangle KIN. By side, 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 which my first side is in line 3, my second side is in line 4, my third side is in line 5. Now I need to complete my T-tool. Make sure that everything is marked. And then I'm done. Are you kidding me? I didn't hit record. I'm going to zoom out a little bit so that you can see the next line that's going to be written. We have side, 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 so now I can go ahead and prove the triangle's congruent. We were given PUM. So the point that corresponds to P would be K, the point that corresponds to U would be I. So that means I want to prove this triangle PUM is congruent to triangle KIN. And that's by side, side, side. And my first side is in line 3. My second side is in line 4, and my third pair of sides is in line 5. So we do need this correspondence to exist. And you don't need those notations, nor do you need the arrows. I do, however, need the T-tool. Everything on my diagram is marked. By stray marking, I'm going to erase it. And I did not note here that I used lines 1 and 2 in the subtraction. So I want to go back and do that. And now we're finished.